David Coote. You've probably worked out which one he is already. He's worked for 15 years in software development, including key technical roles on engineering projects. He's also worked in finance for 5 years at large Australian corporations doing financial modelling, analysis and reporting. He has been involved with renewables on and off for several decades and has written on a range of topics for local and overseas renewable energy publication. He was the first residential green power customer in Australia. Hooray! Through the initial City Power scheme in 1995. He has tertiary qualifications in science, computing, accounting and forestry. I hate these people who do so much. And currently doing a food on wood energy systems with other renewables in a 100% renewable energy system. So please welcome our final speaker, David Coote.
Thank you all for coming. Can I sit down again there, please? Well, thank you all for coming along tonight, particularly on grand final leave. I'm Victorian, obviously, and I understand what that means. I think we might have one person in the Swans top there, or just coincidental colours. I'm not sure which. Normally about this time I'm settling into the beers to watch the grand final replay, hoping Collingwood's going to win the 77 replay, the 79, 80, 81, 2011, yeah, etc. But tonight I'm here and I hope I can interest you in some of the stuff I've got to say about bioenergy. What we can see on the screen is actually a forest plot on a farm in Lower Austria. It was quite a large farm, 1,100 hectares. He had about 200 hectares of forest on the property. His family had been on the property since the late 1600s. And they've just been managing this area and other areas on the farm for farm forestry, which I'm sure some of you are aware of. And when I spoke at the Land Care conference up here a couple of years ago, there were some farm foresters. But they run this on a very long rotation. Trees he's harvesting now are 70 to 100 years old. His great-grandfather might have planted some, or another one of his relations. They do this very low impact harvesting techniques. The wood goes off for various purposes. One of the things they do is supply the residues from the forestry activity, on this on-farm forestry activity, to local bioenergy plants. And the farmers love it, absolutely love it. And I'll give you some reasons why as we go through. So, before we start even that though, I want to kind of set a bit of a framing discussion here. I mean, we've had this fossil fuel energy system now that we've been using, as Rob pointed out, increasingly intensively for 100 plus years, 150 years nearly. And it's kind of grown in a certain way. In the car on the way up, I was talking with Mark about path dependencies. When you start doing things a certain way, humans just tend to sort of keep on going that way. And there's reasons for that. It's because we kind of get good at doing what we're doing within certain constraints. And our current energy system works. It's reliable, you can turn a switch on and we get electricity. And the world's not going to thank us if we deliver a renewable energy system which has issues or problems. So there is a responsibility there, and as Mark's pointed out, that's something that's an area of active study at the moment. But there's also certain kind of characteristics of our current energy system. It tends to be large companies that are running it. It's largely centralised. We reticulate energy in one form or another over long distances. Now, with this range of technologies, and we have got this absolutely extraordinary range of technologies now that are actually commercial, that we can actually start deploying to build systems. And they come in a whole different bunch of scales and technologies and sorts of energy they produce and so on. We can use those to build different systems. We can use those to build decentralised systems. Places like Shepparton could quite seriously target 100% renewable using current technologies. And I think that's something that people don't really kind of, you know, there's sort of like not really a really strong understanding of that. There's certainly people talking about it, but we can do it. We have the technology, we can build it. But what we need to do is have the discussion. Do we want to push down energy production to those levels? Do we want to leave it in the hands of larger companies? And I don't think we're having this discussion a lot at the moment. It's starting with community energy projects such as Jeff and John are involved in and so on. There was a congress recently in Canberra that discussed these. But I think communities like Shepparton, you're extraordinarily well positioned to make use of these technologies. You have good insulation, you have biomass, you have agricultural waste, you have a lot of stuff here that you could use for doing this. And this is the kind of place that could make the front running on this kind of stuff. So please keep that in mind as I go through tonight and show you some of the stuff that I'm talking about. So tonight, just a very, very brief overview of bioenergy, a little bit about community scale woody biomass systems, so a bit of material on near zero energy buildings which kind of pull these technologies together at one scale. And also I'm going to talk a little bit about woody mass, particularly combined heat and power, woody biomass combined heat and power with photovoltaics in Victoria. So Jeff, when John originally contacted me, he said perhaps, could I focus on bioenergy? And of course, several of the other speakers have already covered some of that, so there's no point in me regurgitating that. So I'm going to concentrate tonight primarily on woody biomass, but there's a whole range, a whole slew of bioenergy technologies, which again, in a place like Shepparton, you're well suited to take advantage of those technologies. Just to show you the range of technologies, you can see on the left-hand side we've got feedstock, in the middle we've got conversion technology, on the right-hand side we've got the various energy forms you can output. Some of these are completely commercial right now, some of them are just a dream, a scientist's eye on a lab bench, others are in that intermediate stage between laboratory research and commercialisation. And right now, as someone who's doing research, bioenergy is the area of renewable energy which is getting the most research, and there's a number of good reasons for that. So just, as I said, tonight I'm going to focus on wood energy systems, because that's what a large part of my PhD is about. In the last, humans have been using wood for energy hominid species have been using wood for energy for about 1.5 million years. And in that time, we got efficiencies up to a certain point. In the last 30 years, these smaller scale systems, we've made them automated, we've made them very efficient, and they're starting to be used, they've been used extensively across Europe, and increasingly New Zealand's got a very active woody biomass energy sector now. North America's doing quite a bit of it, and a number of other countries are as well. This is an example of some systems in rural Austria. That chap on the left is actually Felix, the landowner for that first shot I showed of the bit of forestry. And those are residues from trees that have been harvested on his property. They usually leave them sitting by the side of the road for 8 months or so to dry them out a bit, and then they'll be taken into the bioenergy plant in the local village and used there. The farmers typically have, these fairly small amounts of their property devoted to forestry, farm forestry, which they, as I say, they almost use as a bank. So if things aren't going so well in cropping or grazing or whatever, they'll actually sell a bit of timber. And the harvesting techniques are very well suited to the environment it's working within. It's a different form of forestry to some of what we're used to in Australia. The chap on the right-hand side there is one of the farmers going in to look at these. There's a couple of biomass systems there, biomass thermal systems. They're supplying, I think from memory, it was the local council offices, the local library, local community centre, and it was an old convent or a school or something along those lines as well. He goes in there once a week just to make sure nothing's leaking, clean out the ash, just generally have a bit of a look at it. Automated, reliable, work. Here we've got, top left, we've got the two guys on the right are farmers, they're local farmers from that area. You can see the chip from the residues from the forestry. You can see there's a bit of the mechanics of actually moving chip around. That's the ash bin at the bottom. The ash is generally taken back out to the fields or the forest to put those nutrients back into the nutrient cycle. That particular system, which is a couple of 100 kilowatts thermal, was supplying heat into those apartment buildings, a petrol station, a small commercial building. You can see at the bottom right-hand side, that's actually the heat meters. So when they're selling heat into these places, they're actually measuring the heat and charging the customers accordingly. That's another system in a fairly large kindergarten again in Austria. You can see the auger taking the chip up into the little heater. They put that one in a container because they thought they might want to be putting a bigger system in down the track, so they wanted to have that one so they could pick it up and take it somewhere else. This is just shows you how much this smaller scale thermal technology has grown in Austria over the last 10 years or so, or 30 years I should say. Germany and Austria are having a really red hot crack at going 100% renewable and decarbonising their economies. This technology is one of the key technologies at the moment for delivering that. It's something we don't hear about in Australia for a variety of reasons. We've had very cheap fossil fuel energy here for a long time, and forestry, anything to do with trees in Australia, forestry gets complicated very quickly. But most of the European countries are increasingly adopting this technology and using it extensively. That's a small, what's called steam Rankine cycle fired power station. That's a couple of megawatts. By comparison, the ones in the Latrobe Valley are several hundred megawatts. So it's very small, but it's stuck in the middle of a community. It's run by the local community. It's using residues from the local forestry. It's providing power and heat to the local community. And importantly, the profits from that system are staying in the local community. So instead of what, say, Shepparton is doing at the moment, where they're importing energy and exporting money, they're effectively keeping that energy production within their community, and they're also keeping all the money associated with that, all the profits associated with that within the community. I think this is a really powerful and really interesting model. Now, a couple of megawatt system does take quite a bit of woody biomass to run, and that's not much point building one unless you've got the raw material. But it is something that's, and it is something happening a little bit in Australia. There are a number of these schemes being floated around, suggested. This shows the growth in these smaller scale electricity production systems using that technology in Germany. As you can see, these smaller systems, which are very much at a community scale, that the amount of them has gone up enormously in the last 10 years or so. That shows the distribution of those systems around Germany. Germany, by the way, is a fantastic place to use as a study point because they're just fantastically good at capturing information and statistics and making them available. They take it very seriously. But you can see, again, this distribution of energy production around the country, rather than it being, if you had a similar map for Australia, you'd have this very much concentrated places such as the Coote Valley in Victoria, the Hunter and around the coalfields areas in New South Wales. There's similar sorts of things in Queensland around the coalfields and so on. But if you've got this, this technology, it lends itself very well to decentralisation. That's a small, 3 small gasifiers at a chicken farm in Germany. Now, gasification is a technology that's, I think it's fair to say, has promised a lot and hasn't necessarily delivered. In the last few years, there's some small-scale gasification systems which I think are starting to genuinely be commercial. And this is an example from one vendor. And one of my colleagues actually visited this farm in Germany a year or so ago. They were very happy with it. They're running it a lot of hours, and I'm going to talk about that a bit more in a moment. Over 150 villages now in Germany are over 50% biomass in their energy. So again, these are agricultural towns like Shepparton, where they're using biomass to produce an enormous amount of enormous percentage of their energy. You mix that in with wind and photovoltaics, and you get to the point where you can start to get 100% renewable really quite quickly and cost effectively. And I think Mark might have mentioned that there's a large number of villages or regions in Germany which have gone down that route. I think the important thing for me is to say that pick the technology that works with what you've got, in terms of, like, if you've got good sun, PV is an obvious choice. If you've got biomass, think very seriously about using biomass. If you've got a windy area, but rather than trying to sort of make one form of energy solve all problems, really be very creative and very kind of open to using multiple forms of renewables. That's a graphic done by a German research institute showing economic benefits from renewables. And they've just picked representative sizes of various renewables and done an estimate of how much of the financial benefit of that accrues to the community. And as you can see, there's some substantial benefits. Biomass does very well on that because of the jobs required to collect biomass and to run the power stations and so on. So if we're going to start pulling these renewables together, one easy way to do it is in a building. And so there's this concept in Europe now of near zero energy buildings. That's where most of the energy consumed on net basis in a building has actually been generated from a renewable. So you might have exported some of that energy and then brought back in some later on, but net you're actually making most of the energy you consume. Europe's aiming at having all new buildings near zero energy by 2020. I mean, it's like you talk to people in Australia about this, they just kind of, I've had discussions with quite senior people in the building industry, and it's just not realised, I think. Or that's a school I was lucky enough to visit in Upper Austria some years ago. Absolutely glorious setting. You can see that mountain behind it. The school is actually an agricultural training school, which is one of the reasons I picked it as an example for tonight. Very relevant to somewhere like Shepparton. The children who attended are upper high school age. They have their own butcher's shop. They have their own still. They actually learn how to make schnapps. They have their own... I could probably answer that one. I think they have their own brewery. They have their own carpenter's workshop. I think they might have even had a blacksmith's from memory. They certainly had a metalworking area. But The school itself is made almost entirely of wood. It's wood supplied locally within 150 kilometres of the school, so they've tried very hard to make sure that, that even just into the manufacture of the building, that's been done locally and kept money within the community. It has very attractive inside. So it felt lovely. It actually felt really lovely being in that building. The teachers said they thought the fact that it was mainly made of wood actually helped to improve the behaviour of the children. So if there's any teachers in the room that might be interested. That's the training restaurant, which is, they also have hospitality training inside there as well. But it's built to the Passive House energy efficiency standard, which some of you might be aware of. Very, very, very efficient housing. It's a dramatic reduction in the energy used over the previous school building. As I say, it's got a biomass heating system, photovoltaics, the solar thermal. That's the biomass heating system. It's about a 400 kilowatt thermal system from memory. That's Casa Marie and David in suburban Camberwell. This is probably one of the few times you'll ever see an academic flannelette pyjamas on a hill source in a presentation. I thought that was something that needed to be covered. So we've done a lot of work at our place on making it more energy efficient. We also have replaced a lot of our appliances with energy efficient appliances. We have photovoltaics, we have solar hot water, we have an efficient woody biomass heater which we supply from wood collected from local arborists. We have a hybrid solar biomass clothes drying system which consists of putting the clothes horse in front of the wood heater on a wet day and a Hills hoist. It's also one of the few times you see a Hills hoist, I suspect. Hills hoist, by the way, is just the most wonderful technology. It's a massively distributed solar capture system which is cheap, low maintenance, works. We're on, as I mentioned, I've been involved with Green Power for quite a while as a user or as a customer. We use Green Power for our residual electricity demand, and we use very little energy compared to other people. And one of the ways we're actually on the original 66 cents an hour feed-in tariff because we put our PVs on some time ago. But because I'm kind of interested in this area and because I'm a hopeless energy geek, we actually, when we're making excess energy and exporting it, we sometimes will run our electric appliances, like our electric mower and so on, just to make advantage of that, to take advantage of when the sun's shining. And that's actually an approach to making better use of renewables, which has application at broader scales. If you can actually move demand around to make use of when the power's available, that's one better way to get increased utilisation of intermittent power supplies. What about Victoria? Well, this is some of you might know about the biomass boiler that went in at Beaufort Hospital recently, 100 kilowatt thermal. No reason why we couldn't put photovoltaics on that roof, and if I can get the half-hourly data out of them, which I've been after for some months, I'll in fact be able to do that. People say, oh, David, that's all very interesting, but we don't have district heating systems in Australia. And they're right, we don't have them on the size that they have in Europe. But we do have them on campuses. This is a building in regional Victoria. You can actually see the heat reticulation system there that's actually pumping hot water around the accommodation to heat it. That's actually the gas burner that's providing that heat at the moment. And I've done, as Rod said, I'm actually a qualified accountant as well as a scientist. I try to keep the numbers out, but I just couldn't stop myself. I just had to let go. So what I've done here is a bit of modelling around the cost of energy from gas versus the cost of energy from wood. And I've used a variety of prices for wood. And if anyone's interested in why I've used a variety of prices, I'm happy to spend some time on that. But essentially, there's a whole bunch of different places you can get wood. It can come from arborists like we burn it. It can come from tree management, from councils. It can come from roadside management. It can come from plantation forestry residues. It can come from wind throw. There's a lot of places you can get wood from, which avoid the whole native forest harvesting issue, which of course is where people tend to get off on a tangent in this area. But what's interesting to me is that you can actually save substantial amounts of money using a wood thermal system right now compared to both natural gas and LPG, depending on the number of hours a year you're using the system for. And as we've heard a couple of times tonight, the price of gas is about to go up enormously. And that's just going to make these systems that much more competitive. That same site has got an extraordinary amount of roof space. You could easily get 500 kilowatts of PVs up there. And I know I'm actually doing some modelling on that side at the moment around that. So that's a very large 90 kilowatt system on a winery site in South Australia. This size of installation is starting to become increasingly common. I think Gordon mentioned that, and there's actually a couple of large 100 kilowatt systems going in up around here, which they pay around, I think, around $1.30 a watt or so, in that sort of order for. Okay, I've really unleashed the beast here. That little gasifier I showed before, you can actually, as well as making electricity, you can also make heat by tapping water, hot water from the engine jacket. And so it's a little combined heat and power plant. If you can sell the heat that actually at a price, say, equivalent roughly to what it's currently going for from LPG or natural gas, then that reduces the price you can sell the electricity at. So what I've done here is I've, at a site that's paying 11 cents a kilowatt hour off peak and 24 cents a kilowatt hour, it's a small manufacturer in regional Victoria. I've actually modelled, without going too much detail of it, you know, I've done a sensitivity analysis around the amount of heat sold, operational hours. Also, I've looked at differing plant costs, because actually getting a firm cost of what these things will cost to install can be difficult, and fuel costs per tonne. Where it's green, the cost per kilowatt hour is underneath their current peak charge, if you like, or their peak tariff. So it's kind of intriguing that, you know, that the system right now could be generating electricity and heat and being competitive with current fossil fuel energy prices. But you need to be selling a lot of the heat, and unfortunately this particular site doesn't have a great thermal demand on site. I picked that deliberately. They're very keen to get a system like this in, but they want to be able to sell the heat, obviously. So you can do that by putting in small pipelines to neighbouring buildings. This is very common in Europe. I mean, farmers will sell heat to the next door farm. It's that sort of doable and that easy. So, and they actually have a number of buildings around them that could potentially take the heat. The other issue is they've just put 30 kilowatts of photovoltaics on their roof. So I've actually modelled their usage, which is that kind of squiggly line, versus the, that's on a total hours across a year, total kilowatt hours across each hour of the year, added for each hour. I hope that made sense. It didn't sound too good to me. So the squiggly line up the top, that's their sort of initial consumption. The square graph is the production from PVs, which has the classic kind of bell-shaped curve that you're all very familiar now from Rod's introduction. Then we look at the remaining consumption on site and how much we're exporting. We end up with a residual curve, and that's the residual curve of how much consumption remains on site after having that 30 kilowatts in action. That line at the top is if you had a 40 kilowatt gasifier there making electricity. Now, and I hope I'm going to get my little pointer to do the little red thing here. It's not real good, is it? This area in here, if they could sell that energy, then as I showed previously, they could get a levelised cost of energy that was competitive with their current usage. But they need to be able to sell some because it's stuff that's outside their usage, their consumption. What I think is kind of interesting is if we go back to the model that used to dominate the power supply industry going back 100 years or so, where you had a whole lot of little power suppliers selling energy across Victoria. There are actually quite a few of them. There's a number of ways of doing this, and I won't go into it, and I believe there has been a bit of talk about community energy systems here and so on. If you can make it at about 24 cents, if you add a little bit on top of that for retail and a bit for distribution, you don't have to worry about transmission because you're not chuffing power around the country, and you've already got the generation cost built into that figure on there. It starts to actually kind of stack up. You could have little systems like this dotted around the place, integrated with photovoltaics, generating electricity and selling into the local community. So just to wrap it all up, these systems are commercially available. I would want to see a gasifier or two of these types in operation as demonstration sites before saying we should go and put a lot in. But PVs obviously and the biomass thermal systems, they both work fine. If we do some clever design and integration, then we can build these integrated systems. We can get a whole bunch of benefits out of them, including, as I say, the energy resilience, local economic benefits, use of waste streams, and a bunch of other stuff. But you do need sustainable bioenergy feedstocks. And I had to put farm forestry at the end there because, as you might have picked up, that's something of a passion of mine. And that's it. So I think it's time for questions then.